let's think about the maintenance end of the digital twin. Because if we're saying it's not one system, we're across multiple systems, you now have a question of consistency of information across those systems. It becomes very expensive to do that manually. So one way you can handle it is to make a change management process, and you rigorously have to go through, you change this system and therefore you then have to change this, and this. Do you think should we be developing intelligent tools? And maybe this is a role for AI, maybe not AI, but certainly pattern recognition software, or something that could use the relationships in the data, the digital twin or common data environment, to audit the consistency across those systems, like a process that runs in the background.
Yes, I think we could. That's what we sort of do now on projects. For example, we know that the pipe is defined by the process engineers in a process simulation model, and then it finds its way onto the PNID and eventually into the 3D model as a route. They've all got the same name, and what we need to do is say, well, did the pipe that the process engineer simulated in his HYSYS model, for example, did that get correctly represented in the PNID? Did that then get correctly passed over to the 3D model, where the piper made it into a piece of physical material, and then onwards into the actual build?
But that problem in itself is huge, because in HYSYS, as your process simulation, is one pipe, and it probably doesn't have the pipe name. It probably has just a 2-digit number in the simulation, and when it gets into the PNID, often it's actually 20 different sections of pipe, because there'll be the straight sections, the corners, the elbows, the T's, the reducers. They're all entered as separate things, and so the idea of the pipe at the lowest level, it doesn't even exist. All you have is pipe segments.
I think we generally group them all together in the 3D model as the pipe that has its same name as on the PNID. Right. And I think when it comes down to the process engineer running the simulation, probably that's true earlier on in the life of the facility, especially when you haven't decided what concept you're settling on. But nevertheless, the pipe name does tend to persevere these days. So you can trace, it may not be the same, but you can trace through the whole chain. And I tend to take the view that the simpler this is, the better for everyone. So I would like it if the process engineer did use the same as the pipe name, or some way of interpreting it and translating it into the one that ended up in the 3D model, as it were.
This knocks onto a good, we haven't used the word perhaps integrated so much in this discussion, but the digital twin is very much integrated. So the PNID, I see the PNID overlaid totally with the 3D model, overlaid with the process design, and ultimately with the operational. So just to the pipe example, if something is changing on that PNID, then it's integrated with a need and a change on the physical, being the pipe or the steel or the support. So that does get worked out through, and the digital twin is great for capturing all that, Murray, and then for communicating it. Because remember, someone's building this as well, and getting that through to the folk that are actually in fabrication, and then that quality check back for the as-built. So I think it covers this very powerfully. I've seen some really good examples of this working.
Yeah. So just talking there, actually, one of the other things that it makes me think is the digital twin isn't cheap. That actually all we've been describing is actually it's work.
But it's adding value over the life of the facility, over the life of the project, and it's going to continue adding value into the operation, even though it's expensive. It's less expensive than the alternative.
I would use the word investment. I think that's the right thing to do. And as I mentioned before, what's the product? What's the benefit? Articulating that as an industry and as individual companies, and as, most importantly, probably as an integrated solution to the client. What is the product? What's the benefit? What's the cost of the service, and how does it fit? There are huge benefits and outcomes in safety, in cost, in schedule, reliability, predictability, all these things. We have to have the leadership to actually take the client to what those are, is my opinion on this. And there's more to go in that area, would be my observation.
Yeah, okay. And so to the point then about the journey, because Dave, you make an interesting point about the need to evolve towards this. I guess that comes from the reality that you can't just hit the stop button on an operation and switch out to a different way of working at all. It has to go step by step. And so do you see a route from where we are now to a much more integrated digital way of doing it? And just speaking in practical terms, like actually, you know, we're going to have these systems for initially.
Yeah, I can. I think actually you don't have to change very much initially. What you have to change is the underlying data model. So you don't treat your maintenance management system as an entirely separate thing from your engineering environment, and an entirely separate thing from the scheduling environment. Take those three examples. You treat them holistically and you join them together. That's what we've been trying to do on our projects lately, so that you can then say, I need to know when this item is going to be erected. It's really easy because the item has a reference to the activity code that is something to do with the erection sequence in the planning tool. So you can say this is associated with that, and then I can see the dates for putting that object out on site as an example, right? Yeah. So it's all about using what you've got, only using it in a more value-adding way, so that all this stuff is adequately joined up. So that's one of the key things, really. But that has value when you're planning construction anyway, because you've got to do that work. You've got to say, well, when do I have to start manufacturing of that item in order that it gets out of the factory gates, onto the ship, across to the construction yard, in time for it to be put up on site anyway. So that's happening anyway. It's not, there's nothing new about this.
So are you just saying that to do digital twins, the first step is just extending the engineering numbering philosophy early in the project and enforcing it across stuff? Is it really that simple?
Well, that's what I've been doing.
Yeah, it's getting a structured approach and building it in from the start, Murray. I agree with what's been said. To go back on the comments of cost, you know, it actually through if you break it down into the engineering, procurement, construction, commissioning, operations, I think you have to. I would say the phases through the engineering, procurement, construction, I think we're doing what we normally do anyway, but it's reinforcing really good sound practice and giving us an integrated product. I don't think there's more cost. That's my personal view. Then it's a client decision when you go into operations, whether you're going to keep this thing updated and live through the operational phase. And that's where the investment comment I made.
Yeah.
That's certainly tremendous benefits.
Yeah, I think that's where I'm coming from with the not cheap. It's that, well, there's two aspects. One is you have to be committed to it and then maintaining it. If you start a project with one, then you have to maintain it through operations. But the other is if you're retrofitting one, if you're coming in to do this from scratch, to sort of caricature the process that it normally goes through, I guess it's like, right, let's have a digital twin. Okay, where's all the information? Oh, it's in a mess, isn't it? Oh man, how are we going to sort this out? That's going to cost, and there's no magic. There's like, how can we magically run some scripts? Oh, we can't. We need to have people actually unpicking it. And it's that initial cost, which goes to your point, Dave, I guess, of sorting out the information standards early on really pays dividends in the future because of that consistency. That even if you just made the naming convention consistent across all systems,